All right, today we're looking at Chapter 11, Radicals, and we're looking at Section 11.3, Multiply and Divide Radicals. All right, so when we're multiplying radicals, one thing we need to have is the same root to be able to use the product rule for radicals, which is going to be a key power tool we can use. And so we either have to have n is equal to 2 or 3 on all the different radicals that are together. And so the product rule for radicals says that if we have a and b are two positive real numbers, then the square root of a times b is equal to the square root of a times the square root of b. And this works for the nth roots as well. So we'll have the nth root of a times b is equal to the nth root of a times the nth root of b. Okay. And what we're going to do is we're going to multiply radicals with variables. And so basically we're going to follow the product rule for radicals, which is, this one. And we're going to combine the two radicals into one, and then we're going to simplify. So we're going to distribute over any parentheses we need to, when we multiply a monomial times a polynomial, or we're going to FOIL when we have two binomials, or we're going to have special products if we have perfect square trinomials, difference of squares, all those things we kind of had to remember back when we did factoring and stuff. This is kind of same thing we're going to do now, except we're going to use square roots and things like that to simplify our radicals. Now we can also have quotients when we have radicals. And so here what we want to do is reduce the fractions to the most simple form by reducing coefficients outside the radical and reducing the values within the radical themselves. And so for the quotient rules, if we have a and b are any two real numbers, and b, notice, cannot be equal to 0 because we cannot divide by 0, then the square root of a over b is equal to the square root of a divided by the square root of b. Now a lot of times what we're going to do is we're going to go this direction because we'll have two radicals, and if we put them underneath, then we can cancel easy, and sometimes it gets rid of our denominator, and then we just have a numerator, and then we have some square root of some numerator, and it makes things a little easier than just having that denominator with the radical, because eventually we're going to have to get rid of all radicals in the denominator. Okay, now this works for the nth root too. So, we have the nth root of a over b is equal to the nth root of a over the nth root of b. Okay, and again, sometimes we go this direction and not just the forward direction. Sometimes we do the backwards, where we take the two separate ones, put them together into one, and reduce, and then we simplify our radical altogether. All right, so let's look at this one. So the first thing we're going to do is we're going to say, okay, well, what can we do? Is there anything we can do to simplify this? Well, what we're going to do is we're just going to say, okay, well, that's going to be equal to the square root of, and we're going to have 12 times m times 15 times m, okay? And so we've put it all together. Well, what is 12? Well, that's 4 times 3. What is 15? Well, that's 5 times 3. Well, here I see that, okay, well, I've got 4. The square root of 4 we know is 2 because that's 2 squared. And here I have 3 times 3, so that's times 3 squared. Well, here I've still got m times m, so that's m squared. And then the last thing I have is times 5. So what we've done is we've broken all the pieces down underneath here. And so now what that says is we have the square root of 2 squared times 3 squared times m squared times 5. And when we take the square root of 2 squared, well, that gives us 2. The square root of 3 squared is 3. The square root of m squared is m. And the square root of 5, well, that's just going to be the square root of 5 because we can't reduce it or simplify that. And so 2 times 3 is 6 m, and then square root of 5. Okay, so we put everything under one radical, use the product rule, then we simplified, factored each of them, and then looked and saw what we had, and we saw we had a 2 squared here, and we had a 3 squared, and then we had the m squared, and then just the 5, and then we just went ahead and simplified from there. All right, well, what about the next one? Well, here we're going to kind of use the rule where we take that monomial times each piece of the binomial, kind of rainbow it across. So now we have the square root of 6 times the square root of 2 plus the square root of 6 times 2. Well, here, this becomes the square root of 6 times 2, which is 12, plus, and then this just becomes 2 square root of 6. Okay, well, what does 12 do? Well, that's 4 times 3. We know that one from a lot of them we've worked with already. And the square root of 4 is 2, so that gives us 2 square root of 3. Well, 6 is just 2 times 3. That doesn't help us at all. So that stays 2 square root of 6. Now these are not like radicals, and so therefore we can't do anything with them. And so that then is really just our final answer. We've simplified the monomial times the binomial, and we end up with a binomial in the end. All right, same kind of thing here on the next one. We're going to multiply this times this, and then this times this. And so when we take the first one times the second one here, or the monomial times the first term here, I should say, we have 5 times 5n. So that's going to give us 25n, and then times the radical 10. And then plus, now we have 5. We'll keep that 5 out front. Then we have square root of 10 times the square root of 2. Well, that's going to give us the square root of 20. Okay. Now 10, well, that's 2 times 5. There's no perfect square there, so we can't do anything. But 20 is 4 times 5. We can take the square root of 4, and so this becomes 25n square root of 10. Now this one becomes plus square root of 4 is 2 times 5, which is 10, and then we have square root of 5. Okay. Now here we don't have like radicals again, and so then that will be our final solution. We'll have a radical 10 on one and the radical 5 on the other. All right, well, what do we know about this one? We have a binomial times a binomial. So what we're going to have to do is we're going to have to take first times first, and then we can say, okay, well, then we do outer for FOIL, so then we'll take outer times outer, then we'll take inner times inner, and then we'll take last times last, okay? And so when we do that, the first times the first, square root of 5 times 2 times square root of 5, well, that's going to be 2 times the square root of 25. Then we have outer, so we have a negative 1 times the square root of 5, so it's a negative square root of 5. Now the inner, we have 5 times 2, so that's going to be a negative 10 square root of 5. And here we have a minus 5 times a minus 1, so it's going to be plus 5. Well, now we can simplify. Well, what is 25? Well, that's 5 squared, so the square root of 25 is 5, and 5 times 2, that's 10. Now here we have like radicals, so minus 10 minus 1 is minus 11 square root of 5, and then we still have plus 5. So now we have like terms again, because those are just two numbers. 10 plus 5 is 15. Then we have minus 11 radical 5. Okay. And then that would be our final solution of the product of these two binomials here. All right, so same thing here. We're going to take the FOIL method. We're going to take first times first. So minus 5 times a minus 3, that's going to be a positive 15. Then we'll take the outer, so we have a minus 5 times a minus 4 radical 3, so that's going to be a plus 20 radical 3. And then here we have a minus 4 radical 3 times a minus 3, so that's going to be plus 12 radical 3. And here we'll take a minus 4 radical 3 times a minus 4 radical 3, so that's going to be a plus 16. And then we'll have radical, and then it's going to be 9, because we have a radical 3 times radical 3, so it's going to be radical 9. All right, so here that gives us 15. And then here we have like radicals, so we take 20 plus 12, so that's going to be plus 32 radical 3. And what is the square root of 9? Well, the square root of 9 is 3, because that's 3 squared. So we have 3 times the 16. And so that's going to give us plus, what's that, 48. Okay. Now we have 48 plus the 15. And so that's going to be 63 plus 32 radical 3. Okay. And so that would be basically our final solution to this, and so that would be all we'd have to worry about. All right. Again, it was nice we had radicals that were like, so we could add those together, and then the square root got rid of that radical, and so then we could add all the numbers together there. All right, what about the next one? All right, so what do we know about these? Well, let's kind of simplify. So square root of 5, we can't do anything with that. Well, what is the square root of 125? Well, that's really 25 times 5. And we know the square root of 25 is 5, and then we have the square root of 5 left over. So that's 5 radical 5. So 4 times 5 is 20. Then we have radical 5. Well, guess what? Radical 5 cancels radical 5, and we get 1 over 20. Okay. All right. So that was the simple one. Somehow it got moved over. All we had to do is simplify. The radical 5's canceled. All right, what do we have here? Well, on this one, we see the square root of 4. Well, the square root of 4 is 2, so this is 2 squared. So really on the denominator, we just have 6. So that's going to be 2 radical 3 over 6. Well, 2 will go in here once. It'll go in here 3 times. And so we get a radical 3 over 3. Okay. So that one, again, fairly simple, straightforward. All right, so here's one where it's probably not quite as straightforward. So what I'm going to suggest is I'm going to bring everything under one radical. Remember, we could have taken everything under one radical and split it into 2, but this time I'm going to go the other way. I'm going to take the 2 and put it into the 1. That way I can see I can cancel things a lot easier. So let's change our color here. So 3 will go into 3 once, and it'll go into 12 4 times. That p will go in here once, and it'll take out one of those. And so now what do I have? Let's rewrite this. So what I have is I have basically nothing on the bottom. They're just ones. So I have the square root of 4p on top. Well, square root of 4 is 2, so really all I have is 2 square root of p as my answer. Now, there's other ways you could do it. You could have come up here and said, okay, well, that's going to be, 4 times 3, and so that square, that's going to be 2, and then I'll have square root of 3, and then I'll have the p squared over the p, and I can cancel the p again and get the square root of p here. There's a lot of different things you can do, but I think this one is probably the most simple, putting it into 1, canceling everything that'll cancel, and then we get our 2 square root of p. All right, what do we have here? Now, notice we have the cubed roots, not the square roots. We're back to cubed roots. And so, well, what is 625? Well, that's, let's see, it's 5 cubed times 5, so it's 125 times 5. And so that's what that is equal to. And so now, when I take the cubed root of this, I'll have, well, the numerator doesn't change. So it's a cubed root of 5. The cubed root of 5 cubed is going to give me 5, and I still have times 4, so 5 times 4 is 20. And what's left over here is the cubed root of 5. Okay. Now, I really don't need to change colors because there's not much left, but that will cancel that, and we get our simple 1 over 20. I believe we got that answer one time before, but this time it's for this problem number 9. All right, so what we have here is we're kind of back to the easy problem. So I'm going to do this one, and then I'll stop the video and then make another video with a bunch more problems to work. All right, so here what I'm going to say is, let's say this is still 5, and we're going to bring everything in the middle. So that's going to be 10 times 15. Okay. Well, what is 10? Well, that's 2 times 5, and 15 is 3 times 5. So I've got 2 5s here, so that's a minus 5 square root of 2 times 3 times 5 squared. Okay. Well, the square root of 5 squared is 5. 5 times negative 5 is going to give me negative 25. And 2 times 3, well, we can just put that back as 6. And so we get a negative 25 times the square root of 6. Okay. So I'm going to stop there, and I'll start another video for you for the second half.